Hi, good morning all. Today's session it's about flip-flop in computer organization and architecture. So these are the outline flip-flop and the types RS flip-flop, D flip-flop, JK flip-flop and T flip-flop. A definition of flip-flop. Flip-flop is an electronic circuit with two stable states that can be used to store binary data. The stored data can be changed by applying various input. Flip-flop and latches are fundamental building blocks of digital electronic system used in computers, communication, and many other types of system. Flip-flop versus latch. The primary difference between latch and flip-flop is a gating or clocking mechanism. In simple words, flip-flop are edge triggered and a latch is level triggered. And the types of flip-flop: SR flip-flop, JK flip-flop, D flip-flop, and T flip-flop. So these are the four main types of flip-flop in digital electronics. SR flip-flop. This is the most common flip-flop among all. The simple flip-flop circuit has a set input S and the reset input R. So that's why it is called RS or SR flip-flop. In the system, when you set S as active and the output Q would be high and Q would be low. Q dash will be low. Once the output are established, the wiring of circuit is maintained until S or R go I or power is turned off. As shown above, it is simplest and easiest to understand. The two outputs as shown above are the inverse of each other. The truth table of SR flip-flop is given. So S and R, these two are the input and Q dash will be the output. So when S and R 0, the Q will be 0, Q dash will be 1, and S is 0, R is 1, Q will remain 0, Q dash will remain 0, 1, and S is 1, R is 0. So the change in Q. So 0 will be changed into 1 and Q dash will be 0. Again S is 1, R is 1. So infinity means there is no operation on this value. So JK flip-flop is an improved version of SR flip-flop where the undefined state of SR flip-flop is eliminated by providing feedback. JK flip-flop logic diagram also given here. JK flip-flop using NAND gate only, but here we have taken a circuit that uses AND and NOR gate, just like we discussed in SR flip-flop. Yes, of course, in the logic gate we could able to see J and K and the clock symbol also. The output will be Q and Q bar. JK flip-flop is an improvement on the SR flip-flop where S equal to R equal to 1 is not a problem. The input condition J equal to K equal to 1 gives an output inverting the output state. In simple way, if J and K data input are different, then the output Q takes the value of J at the next clock edge. If J and K are both low, then no change occurs. If J and K are both high at the clock edge, then the output will be toggle from one state to other state. JK flip-flop can function as set or reset flip-flop. Okay, so according to the points I have given, the truth table is formed. The input values are 8. J and K are the input and Q and Q dash will be the output. So next type it's D flip-flop. D flip-flop or data flip-flop or delay flip-flop can be designed using SR flip-flop by connecting a NOT gate in between S and R input and tying them together. D flip-flop can be used in place of SR flip-flop where you need only set and reset state. D flip-flop is a better alternative that is very popular with digital electronics. They are commonly used for counters and shift registers and input synchronization. The logic circuit given here, so D and clock are the input, the Q and Q dash will be the output. The output can be only changed at the clock edge. If the input changes at other times, the output will be unaffected. The change of state of the output is dependent on the rising edge of the clock. The output Q is same as the input, can only change at the rising edge of the clock. So the clock value given here, um, and D value is given here. According to that, Q and Q dash will be set. T flip-flop, it's similar to JK flip-flop. Just tie both J and K input together to get a T flip-flop, just like D flip-flop. It has only one external input along with a clock. T is just like a JK flip-flop. There are basically single input version of JK flip-flop. This modified form of the JK is obtained by connecting input J and K together. It has only one input along with the clock input. So the logical circuit diagram of T flip-flop, here it is given. So inputs are T and clock. According to that, we'll get Q and Q dash. These flip-flop are called T flip-flop because their ability to complete that state, i.e. toggle, hence they are named toggle flip-flop. So T and Q, so Q dash equal to T plus 1. The applications of flip-flop, these are the various type of application being used in digital error cutting circuits, and the application of flip-flop are as specified below: counters, frequency dividers, shift registers, storage registers. Yeah, thank you.